So we're talking this morning via Skype with Andy Clegg from Industrial Systems and Control in Glasgow. And one of the things that you've been working on, your group, well, first maybe you can tell us a little bit about your group, but then tell us about this project that you've been working on with the Fieldbus Foundation. Now, what exactly is Industrial Systems and Control?
Okay, well, we're a spin-out company out of Clegg University, but quite a long-established one. 25 years ago, it was when we were set up by Professor Mike Grimble, and but we're still a relatively small consultancy company. We've got 7 engineers, all of which are fairly well educated in control and also in the sort of practical aspects of solving real-world control problems. And we work in a very wide range of sectors. So we do have a lot of experience, and we've had a bit of a relationship over the years with Foundation Fieldbus, who've engaged us a couple of times now to carry out some impartial work evaluating the performance of control in the field in terms of control loop performance and the sort of benefits it can accrue over more traditional control methods.
So the nature of the projects that you've been working on for the Fieldbus Foundation have not been so much technical in the sense of you're not working on trying to develop the control in the field technology as how it's applied and how it works when it's actually applied in the field.
That's correct. Yeah, what we were asked to do is we actually really kind of come up with a practical, pragmatic evaluation of the performance benefits that control in the field could deliver when it's actually applied in the field.
So is this something you've done there? Do you have a lab set up, or is this something that you have done in actual field installations?
No, in the studies we've done, they've been entirely kept within the simulation domain, but we've been quite rigorous in making sure that we are treating it as realistically as possible. And the reason why we've used a simulation environment is because it allows us to control the environment and control the scenarios that we're evaluating. We are talking to Fieldbus to actually take some of these results and try them and apply them to the real world. But in this first phase of work, it was quite important to get a very good and clear understanding of how the effects all were interrelated. And you just can't do that on the real plant because there are so many other variables that cause the results to be deviate from where you expect them to.
So what types of loops are you simulating? What kinds of applications would this be reflecting in the real world?
We've tried to treat them as a whole range of process control loops, ranging from very fast process control loops like flow and pressure, ranging all the way to very slow control loops. Specifically for the actual evaluation, it doesn't actually really matter what the process variable actually is, more around the dynamics of the process in terms of how fast it is. And this is quite important because we have in the process industry you have a very wide range of process dynamics. And I think it's fair to say that the results that we've produced from this analysis is predominantly showing that it's only on the very fast, on the fastest loops where the performance of control in the field is very significant, and on those slower loops there's negligible performance benefit between say 4 to 20 milliamp loops and control in the field. So we really it was really useful to understand that and understand where the boundary lied between the performance benefit and where things were tailing off a little bit.
So it was a situation where you were looking at not just where does it work, but where is it the most beneficial?
Really around trying to understand when the performance benefits actually materialized. It's not very credible if you try and quote these numbers and say this is the performance benefit you're going to get, because people, engineers know that these things are dependent upon so many variables that you've got to kind of put caveats around these limits and say and clearly explain when these benefits are going to arise.
So what were some of the situations where you found that the benefits were greater or more in line with what you had expected?
Well, the good thing is that a lot of these findings are actually agree with common sense, which is always a good starting point. We found that the benefits of the very highly deterministic nature of control in the field really came into its fore on the very fast process control loops like pressure and flow. So if you've got pressure and flow loops, the performance there probably improved by we were predicting between 10 and 15% performance benefit over the, say, a 4 to 20 milliamp loop. Now, obviously, as the loops got slower, that performance benefit decreased quite quickly, such that anything above around a loop that was, say, with a 50-second or a 1-minute settling time, the performance benefit there was getting into the point where it was getting marginal. So it's really focusing upon the fast loops, and also importantly, it's also affected by the dynamics of the disturbances that the control loop is trying to control against. So if you've got disturbances that are very fast, either step changes or random walk type effects, they benefit the most. Whereas if you've got a slowly varying disturbance, say like ambient temperature, which is very slow, but any sort of slowly varying disturbance, there's not going to be any performance benefit there as you'd expect.
So basically, the main advantage of control in the field is this determinism, and
But
where, or is there more?
there are a lot more benefits to using control in the field over than just the simple determinism. But we were just looking at purely at the control loop performance, i.e., how much the variability is reduced by control in the field. I mean, in terms of the additional benefits, there are things like the availability of control in the field, because control in the field allows if you've programmed it correctly, allows loops to be reconfigured should things go wrong. It also has easier installation costs, maintainability issues that are better. There's lots of ancillary benefits that probably are significant in their benefit for a process plant. But we were just looking at the control loop performance aspect, because I think this was often something that was often cited by people as being a benefit, but nobody had really quantified how much benefit it was. I think it's certain to say that within the control in the field, you probably have the ability to run with shorter latencies, faster scan times, which will allow better performance. But we were trying to compare things on a fair basis, so we were trying to keep the performance aspect kind of quite separate.
Do you find that users are interested in using control in the field to offload some of the processing from their centralized host?
Yeah, that's a good point. I mean, that's probably one of the main areas of benefit that you can use control in the field for. If you've got a very fast control loop and you've got a bottleneck in the processing or networking capability when you're trying to use a centralized control, then offloading that to control in the field is certainly very advantageous, because not only do you end up with a much more deterministic control loop, you're placing a higher criticality on those computations taking place in a very determined way.
So, as someone who you yourself have worked in these types of applications, where would you recommend this? Where would you use it yourself? What types of situations?
Oh, that's a good question. Well, certainly, I mean, the benefits are by far the strongest in fast control loops, pressure and flows. But you also have to bear in mind that there's got to be an economic benefit attached to that control loop as well, because many flow loops and pressure loops might just operate okay in a process plant and don't have a great impact upon the economics of the plant. That should position your thinking as to where you need to place the most effort for control in the field, and even the wider control loop maintenance aspect of things. Making sure the tuning's on the button, making sure everything's working well. They should always be driven by the loops that have got the biggest impact economically. Within the study we've just done, we actually did a small section where we were looking at how the variability reductions that we were talking about could extend and give some economic value into a plant. So, and one of the loops that well that I'm fairly familiar with is steam temperature control in a power station. So the temperature of the control of steam within a large, say, fossil fueled power station is quite critical. We took the results from the study that we did in simulation, and we said with this type of speed of loop that matched the temperature control loop, and here's the potential variability reduction that we expect to get from controlling the field. The annual benefits from that loop are still quite large, even though the percentage variability reduction is quite small. It's just because that is a control loop that's very important economically for the operation of a power station.
That makes sense. You talk about this study being compiled. Is this something that's going to be available through the Fieldbus Foundation?
Yeah, our previous reports were made available publicly, and I believe this current one will be made available as well. I think we're just finalising the final version of the report. That will then be issued to the Foundation Fieldbus, and then they will issue it as they feel appropriate. So we've written it in a way that is a useful read for people who don't need to know the detail of how we've done it, but it just presents the results and presents the findings in an easy to digest way. So I believe that they will be making this available publicly, I would think.
So we should be watching this space for announcements.
I would hope so. I would hope so, and I think that hopefully that at some point we'll extend this by actually doing some tests on a laboratory piece of equipment just to validate our findings and just give them that little bit more credibility when you've done the tests on a real plant. But as I said, one of the difficulties with that is the fact you've got to have some really constraining environmental conditions, because otherwise there's too much variability in a real plant to really pick out and isolate those benefits, and be completely sure that they are occurring.
Okay. Well, thank you, Andy. It's looks like kind of a gloomy day in Glasgow, but I hope it
It
clears
is.
up.
Okay, thank you.
Thank you.